we're going to work on some problems that specifically target conditional or absolute convergence. And we're going to start with one that's fairly easy. Now, this one you could look at and you could say, well, that looks like a geometric series to me. And in fact, it is a geometric series, so you should know something automatically about it. But we're going to try, so this is a really good example of is, okay, well, I'm going to try to just do this absolutely. I'm going to say I'm going to put an absolute value on it and just go with it. So if I take the absolute value of this, then that alternating term disappears, right? So it just vanishes. So I have 1 over 5 to the n. Well, that's clearly a geometric series, right? It's 1 over 5 to the n. And we know that the radius of that is less than 1. So since that r value is less than 1, it's going to converge. But here's the thing. We put the absolute value on it, which meant that we're actually testing absolute convergence. So it doesn't just converge, it absolutely converges. And just to reiterate, that doesn't mean like definitely or assuredly converges. It really, this specifically relates to using the absolute value operator. So just keep that in your mind. I'm going to keep saying it to try to reiterate that. Now this next one, I have -1 n plus 1 over n plus 7. So the first thing I'm going to do is I'm going to throw an absolute value on it. I'm going to say, okay, well, what about that bad boy? So, again, the alternating term always disappears when you do an absolute value because it's -1 or +1. So the absolute value of that's 1. Doesn't matter if it's negative or positive. It just comes out 1. Now I have 1 over n plus 7. So what I want to do here is I want to use something like the limit comparison test. That's what I'm thinking of doing. Say, all right, well, I'm going to compare that to 1 over n. Because this looks like a polynomial, so what we can do with the limit comparison test is we can compare it to another polynomial that doesn't have, you know, n's and all that kind of stuff, or doesn't have all the extra terms, it's just the leading term. And since that ratio will almost always come out to be a positive, or not a positive, a finite number that's not 0, then we can say, okay, well then these things converge together or they diverge together. So rewriting that, we get n plus 7 over n, which is 1. Hopefully you can solve that limit on your own. So these things have the same, since the limit goes to 1, they're either going to converge together or diverge together. So again, that diverges, well-known divergent series, the harmonic series. So what that tells me is that can't say this absolutely converges, but can I say it conditionally converges? Well, let's check. So I've got an alternating term here. So I could then say, all right, well my non-alternating piece is that sequence, 1 over n plus 7. So I have to say, all right, well, does it pass the nth term test for divergence? Yes, it does, because that limit is 0. Is it always positive? Yes, it is. Because as n goes up, let's just keep on being positive. Now we have to say is it a decreasing sequence? Is the n plus 1th term less than or equal to the nth term? Well, if we cross multiply here, you get n plus 7 is less than or equal to n plus 8. Well, that's clearly true because 7 is less than 8. Or, well, I'll put the check mark here. So that tells me that this sequence, or that this series without the absolute value actually does converge. But with the absolute value, it doesn't. So that tells me that it does converge, but only conditionally. So we can't just slap absolute values and expect it to work, sadly. All right, well, let's come over here. Let's look at this one. I have negative 1 to the n times n over 3n plus 2. So if I slap an absolute value on this, let's get a different marker. So we started at n equals 0, which is kind of dumb, by the way, because if n is 0, this whole thing is 0. So we really should just start at 1. Why not? I mean, it's actually true either way, but it's kind of a dumb notation. So then I have that. Well, if I take the nth term test, here I say, okay, well, I get 1/3. Well, that's no good. That means that diverges. And if the nth term test diverges here, this is also going to diverge for the nth term test. So we actually get a divergent series.